Hi and Assalamualaikum. My name is Abdul KHATTAB. With my partner AIMAN HAKIM are going to present about pipeline management, control and safety. What are pipelines? Pipelines are conduit of the oil and gas industry. It is being used by the industries to deliver energy product from where it produced to where it is turned into a useful fuel and products. Energy product delivered by pipeline include crude oil, refined product like gasoline and diesel, and natural gas liquid such as ethane and propane. A good pipeline management can ensure environmental compliance and efficient operation at minimal cost. In general, there are two different types of pipelines, which are petroleum pipeline and natural gas pipeline. Petroleum pipeline will be used to transport crude oil or natural gas liquid from well to a refinery and produce refined product like gasoline or kerosene, and lastly transported to the storage or distribution station. Meanwhile, for natural gas pipeline, it will be used to transport natural gas from stationary facilities such as gas well or import or export facilities and deliver to a variety of locations such as homes or directly to other export facilities. Oil and gas pipelines in Malaysia. Malaysia has a relatively limited oil pipeline network and relies on tankers and trucks to distribute products onshore. However, Malaysia has one of the most extensive natural gas pipeline network in Asia, totaling about 2,455 km. Malaysia's natural gas pipeline are 1. Peninsular Gas Utilization Pipeline. It is the longest pipeline in Malaysia. The 1,700 km pipeline connecting Kedah Refinery in Terengganu to other areas of Peninsular Malaysia. Second, Sabah Sarawak Gas Pipeline. Sabah Sarawak Gas Pipeline is a 500 km Malaysian natural gas pipeline that link Kimanis in Sabah to Bintulu, Sarawak. The pipeline is part of the Petronas Development Project of Sabah Sarawak Integrated Oil and Gas Project and has started operating since early 2014. Third, Trans-Thailand Malaysia Gas Pipeline. Trans-Thailand Malaysia Gas Pipeline (TTM) is a gas pipeline linking suppliers in Malaysia to consumers in Thailand. It is a part of the Trans-ASEAN Gas Pipeline Project. The development area is approximately 255 kilometers east of Songkhla province in the Gulf of Thailand. Construction on the pipeline started in mid-2003 and was completed in 2006 until 2007. It was built by the Trans-Thai Malaysia Ltd, a project company of Petronas and the PTT Public Company Limited. Next, these are some of the principles of pipeline safety from the United Nations Convention on the Transboundary Effect of Industrial Accident in 2008. First, government should provide leadership, create and maintain administrative framework to facilitate the development of a safe and environmentally sound transportation infrastructure, including pipeline. Second, leaks from any part of a facility or pipeline that contain hazardous substance should be recognized adequately in a quick and reliable way, especially in environmentally sensitive or highly populated areas. Third, deterministic and or probabilistic approach should be used in evaluating pipeline integrity and impact on human health and environment. Fourth, pipeline operators and the authorities responsible for pipelines should review and, if necessary, develop and implement system to reduce third-party interface.
Assalamualaikum. My name is AIMAN HAKIM bin Muhammad ISMAIL, and I will proceed with safety measures in pipeline design and construction. The first safety measures is regarding engineering design. The safety of the pipeline should be demonstrated through a suitable hazard risk assessment procedure, taking into account all incredible scenarios including breakdowns and external additional loads. The static, dynamic, and thermal additional loads to which the pipeline can be subjected, such as stress from soil and traffic loads, should be determined. The influence of pressure surges should be considered in the dimensioning and design of the pipeline itself. Next, we move to materials. Pipelines should be constructed with the most suitable materials available to ensure their integrity throughout their life cycle. The most unfavorable operating condition, such as breakdowns, should be taken into consideration. Next is regarding piggability. The action of cleaning a pipeline via the means of a device that travels through the line is called a pig. Pipelines should, with exception of lateral section and station, be piggable for inspection purposes. Next is regarding corrosion protection. There are two types of corrosion that needs to be considered in a pipeline design, which is firstly is external corrosion and secondly is internal corrosion. Next is regarding fire and explosion protection. Pipelines should be constructed, manufactured, and equipped as well as maintained and operated so as to ensure the safety of employees and third parties, particularly against the risk of fire and explosion. The next safety measure is regarding safety equipment. Pipelines should be equipped with practical and effective facilities for safe operation. Proof of suitability of safety equipment for the operating functions should be provided also. Next is height of covering. The height of covering of buried pipelines, meaning the pipelines are underground, should be adapted to suit local requirements in order to minimize the possibility of external interference. Lastly, the last safety measure is marking. The route of the pipeline and its equipment should be marked in a suitable and visible way. Next, we proceed with Pipeline Management System. The Pipeline Management System, PMS, should include the part of the General Management System, which includes the organizational structure, responsibilities, practices, procedures, and resources for determining and implementing the accident prevention policy. The PMS should address the following issue. Firstly, organization and personnel. Roles and responsibility of personnel involved in the management of hazard at all levels in the organization should be identified. Next, identification and evaluation of hazard, including transboundary hazard. Adoption and implementation of procedures and systematic identification of hazard arising from normal and abnormal operation and assessment of their likelihood and severity. Next is operational control, which means adoption and implementation of procedures and instruction for safe operation, including maintenance of plants, processes, and equipment. Next is management of change, which means adoption and implementation of procedures for modification of processes and storage facilities, including the design of new installation. Next is planning for emergencies. Adoption and implementation of procedures to identify foreseeable emergency by systematic analysis and to prepare, test and review emergency plans for responding of such emergencies. Next is monitoring performance. This means adoption and implementation of procedures for the ongoing assessment of compliance with the objectives set by the pipeline's operators' accident prevention policy and the safety management system and of the mechanism for investigation and taking corrective action in case of non-compliances. Lastly is audit and review, which means the adoption of implementation of procedures for periodic systematic assessment of the effectiveness and suitability of the safety management system. Next, we proceed with pipeline inspection. Pipeline inspections are control measures that should be done at regular intervals by trained staff and qualified, certified contractors. These inspections should focus on whether the pipeline is in proper condition and the functioning of the equipment, ensuring pipeline safety. Inspections should be sufficient for a systematic, technical, organizational or managerial assessment of the systems being used for pipeline. In particular, pipelines operators should demonstrate that they have developed appropriate performance indicators to monitor the pipeline management system (PMS) that I mentioned earlier. Next, pipeline operators should demonstrate that they have taken the appropriate measures to prevent accidents. And lastly, pipeline operators should demonstrate that they have provided appropriate means for limiting the consequences of accidents, and any data and information submitted should adequately reflect the conditions of pipelines. So, in conclusion, good guidelines for pipeline management, safety and control can contribute to a well-constructed, carefully monitored and properly attended pipeline system that can be safe, environmentally sound and economically viable. Furthermore, it can also enhance awareness and sharing of good practices among the competent authorities, operators, and the public. This in turn could lead to a better harmonization of the regulation and requirement concerning the safety of pipeline. That's all from our group. Thank you.